Hello everyone. Let's now look at this worksheet 9 solutions together. So for this worksheet 9, we have 4 questions. Number 1, suppose we wish to estimate the average number of hours that undergraduate students at SHSU sleep per night, and assume the students in this class represent a random sample. Collect the sample below. So the sample we have are 6, 6, 3.5, 5.5, and then 2, 5.5. So we can observe this data set and then calculate the sample mean x bar, which is 5.81, and sample size n equals 13 because we have 13 numbers in the data set. So after we know the basic information, we're going to look at the requirement here. We wish to test a person's claim that undergraduates at SHSU get 6.5 hours of sleep per night. Knowing that the population variance is 4 hours, now we want to conduct a test using alpha equals 0.05. So the first thing we want to focus is the population variance term. So population variance means sigma known. So this is a sigma known case, and the variance is 4. Because sigma squared equals 4 variance, right? Now sigma squared equals 4. So sigma equals square root of 4, which is 2. So step 1, we're going to state the hypothesis. So the null hypothesis is always equal. So mu equals 6.5, and the alternative hypothesis does not equal. So mu is not 6.5. So that's the null and alternative hypothesis. Because in the claim, we don't see a preference, whether it's more than or less than 6.5. So the claim is whether it is 6.5. So that's how we set it up, step 1. And step 2, we want to find the critical value or the rejection region. So let's change that here. So step 2. Step 1, the null and alternative hypothesis. Step 2, the rejection region. So does not equal means two-tailed test. So we have rejection region on both tails, and alpha equals 0.05 and divided by 2. So because it's symmetric, we have 0.025 for the lower and upper shaded area. And since sigma known, so we know this is a normal distribution. So whether sigma is known or not controls the distribution here. So we know that's a normal distribution. So for a normal distribution and one critical value to the right, you have 0.025. So what's the critical value? So that's z sub alpha over 2, or z sub 0.025. And we check the normal, standard normal table. We can get that equals 1.96. Actually, at this point, we all know it is 1.96. And it's perfect symmetric. So the other side, we got negative 1.96. So these two numbers are called the critical values. And rejection region, we have to write it out when we're going to reject the null hypothesis. So we're going to reject the null if the z test statistic gonna be greater than 1.96, or if the test statistic is smaller than negative 1.96, or we say what the test statistic lie within the rejection region, we're going to reject the null. So that's how we describe it. That's step 2. And step 3, we're going to calculate the test statistic. So sigma known, so it's a z test. So that's x bar minus mu naught over sigma over square root of n. So x bar 5.81, mu naught is the mu when null is true. So if we assume h naught is true, then mu equals 6.5. So that's how we got mu naught. So 5.81 minus 6.5 over sigma, which is 2, over square root of n. So then the test statistic is negative 1.2439. And then step 4, we want to make a decision. The test statistic equals 1.24 and negative 1.24. It is not smaller than negative 1.96 because it's a negative number. We only need to compare with the negative side. So we fail to reject a null. That's the decision. And then the last step, step 5, there is not enough evidence to conclude the average hours of sleep for SHSU undergraduates is different compared with 6.5 hours. So 5 steps, and we don't need this here because it's already given. Okay, that's question 1. Question 2, we wish to estimate the mean amount of time it takes students in an introductory statistics class to complete an exam. A sample of 16 students take the exam, and it is found the mean time it took them to take the exam was 48.5 minutes with a standard deviation of 5.1 minutes. So as long as we don't see a population term here, then the standard deviation is considered as the sample standard deviation. So I'll write the null and alternative hypothesis. And if we wish to test if the mean time is greater than 15 minutes, so larger than 15 minutes, we want to finish the test using alpha equals 0.01. So then we can circle some number here, 16, that's our n. Mean time, 48.5, so that's the sample mean. And sample standard deviation as equals 5.1. So that's something we know. And plus what? Alpha equals 0.01. So same thing, step 1, null and alternative hypothesis. Population mean is greater than 50, so mu larger than 50, and then the null is always equal, so just change the sign, and then the hypothesis value is always the same, so mu equals 50. That's null and alternative hypothesis. And step 2. Step 2. So based on our textbook, let's just stay with this textbook. So step 1, null and alternative hypothesis, and step 2, want to look at the critical value or the rejection region. So then we have to look at the sign from the alternative hypothesis greater than. So that tells us is one tail right test, right? So right tail, only one from the right, the rejection region from the right side. So same thing, we can draw this normal distribution, standard normal distribution here. And the critical value to the right, we got a shaded area, that's alpha 0.01. So this is T sub 0.01. And the reason we say, I think I said that wrong. This is not a standard normal. This is a T distribution because sigma is unknown. Sigma is unknown. So we got a T distribution. So this is T sub 0.01. And what T distribution? That's decided by the degrees of freedom, so df, which is n-1. So this is T15 distribution. And the critical value is T sub 0.01 with df15. So we can check the T table and get the critical value equals 2.602. So that's a critical value. We can also write out the rejection region. So we're going to say reject H naught if the test statistic. So look at the sign here, greater than, right? Greater than 2.602. So that's the rejection region. And step 3, I'm going to calculate the t statistic and plug in all known info, x bar 48.5, mu naught, so which is the mean under the null hypothesis 50, and s 5.1 square root of n 16, right? Plug in, that's for test statistic. So step 4, we want to make the decision. So test statistic equals negative 1.1765. That's not larger than 2.602. So fail to reject the null. And step 5, in conclusion, there is not enough evidence to conclude the mean time is greater than 15 minutes. Don't forget to write down at alpha equals 0.01. So this is important. That's question number 2. Question number 3. Now we go back to question 2 and then conduct the test again, but this time test the mean time is under 45 minutes using alpha equals 0.1, and compare the result. So sigma unknown alpha equals 0.1, and with n 16, x bar 48.5, and standard deviation equals 5.1. So step 1, same thing, mu smaller than 45, and the hypothesis value never change, and null always have equal sign, so mu equals 45. And step 2, we can look at the rejection region. Now is one tail left, so the rejection region lies towards the left of the distribution, and this is T15 distribution. So we got negative T sub alpha, because T sub alpha means to the right you have 0.1, and because T is also symmetric around 0, so we can still do the negative of the checked value, and that's negative 1.341. In step 3, we calculate the test statistic. Step 4, decision. The test statistic is 2.7451. It is not smaller than negative 1.341, because if we want to write out the rejection region, we're going to say reject H naught if T is smaller than, so the sign comes from here, or the alternative hypothesis, T is smaller than negative 1.341, or lie within the rejection region. So T is 2.7 something on the right side, is never going to lie within the rejection region, so we fail to reject H naught. In step 5, in conclusion, there's not enough evidence to conclude that the mean time is under 45 minutes at alpha equals 0.1. Question number 4, let mu equals the average number of hours that a student at SHSU spent watching TV last weekend. Wish to test is that average for all students is more than 10 hours. Now just write on the null and return hypothesis, more than 10, right? So mu larger than 10. So this sign comes from here, and this 10 is called hypothesized value. Hypothesized value. And the 10 never change. So after you write down the 10 gonna go here as well. And it's for population mean, right? And null always include equal sign. So we can easily specify the null and the alternative hypothesis. Okay, that's the last question, and that's all for worksheet 9 solutions. Thanks for watching.